Okay guys, welcome back. Again, we've talked about e before, the natural base, or the exponential function. E is irrational, and it's defined as this: as n goes to infinity, this value will approach an asymptote of 2.7182818, and yada yada yada. Okay, and that's how they get that. So we're going to use exponent properties to simplify these. Alright, so even though it's a base e, it's still the same base, so you add the exponent, so this should be e to the 9th. Here, we divide the numbers, we get a 4. We subtract the exponents, we get e to the 1st. Here we square both things, so we get 3 squared, and e, you multiply, to the negative 8x, so we get 9e to the negative 8x. Or, if I do not want negative exponents, I get 9 over e to the 8x. Okay. Now we're going to do it the opposite way now. I know that seems counterintuitive, but sometimes in math you have to split things up or rewrite them to make them work better. So this would be the same thing as saying e to the 5th to the k power. If you have subtraction, that means we divided two bases. The top one was e to the 3k, and the bottom one is e to the 4th. If I'm adding two exponents with the same base, that means I multiplied the bases together with those exponents. So that's how you can split those, just using exponent properties. Okay, we kind of graphed these already, but just to reiterate, exponential growth, you get the values when x is equal to 0, you get y is equal to 1. When x is equal to 1, you get y is equal to 2.8 or 718. Sorry. And then when x is 2, you get 7.389. So we get that, and something up there, and then it approaches 0 like all the other exponential growth ones, unless there's a shift. If it is e to the negative x, that's like 1 over e to the x, it's the opposite. 2 and 7. So it looks something like this. Alright, so you could have just graphed those in your calculators and looked at those. So what we're going to do today is graph exponential functions and then the inverse, alright, and look at those. I'm also going to talk about domain and range real quick when we're doing that. So the first one, and I'm going to, guys, I don't want to get the calculator up again. You can use your calculators to graph these. We do not know how to graph the inverses yet because we don't know what those are, but for now we are going to use our calculator. 2 to the x, when you fill out this table, you get these values. So I get 3, 8, 2, 4, 1, 2, 1, and then 1/2. Okay. And it's basically going like that. Okay. Now remember, for inverses, you switch the x and y. So when x is 1/8, y is negative 3. When x is 1/4, y is negative 2. When x is 1/2, y is negative 1. When x is 1, you have 0, 2, 1, 4, 2, and 8, 3. So I'm going to plot that. When x is 1/8, we're down at negative 3. When it's negative 2, we're at 1/4, negative 1, 1/2, 1, 0, 2, 1, 4, 2, and 8, 3. Notice that this looks like we have an asymptote that's vertical, which makes sense because if the other one has a horizontal asymptote, this one has a vertical asymptote. So remember, the original graph has a domain of all real numbers and a range of greater than 0. Notice how that switches with the inverse. Now our domain, or x values, has to be to the right of 0, and the range will go up forever, slowly, but it will go up forever. So that's all real numbers. Okay. Let's do that again for 1/2 to the x. So when you have negative 3, this kind of flips it. It's 8, 4, 2, 1, and then 1/2, 1/4, 1/8. And if you do the inverse, we have 8, negative 3, 4, negative 2, 2, negative 1, 1, 0, 1/2, 1, 1/4, 2, and 1/8, 3. All right, let me graph the original in blue. So negative 3, 8 is up here, negative 2, 4, negative 1, 2, 0, 1, and then 1/2, 1/4, 1/8. So it's just the reverse of, it's the decay form of 2. So there's that. Also note on the first one, by the way, that is a reflection over the line y equals x. And then we have 8, -3, 4, -2, 2, -1, 1, 0, 1/2, 1, 1/4, 2, and 1/8, 3. So we have an asymptote here that is a vertical asymptote, and that'll just keep getting bigger there. Okay? Alright, so that's the inverse. The red is inverse, blue is original. Okay, for this one we're going to do some shifts. I'm going to use the calculator to get these values again. So in my calculator I noticed that like -1 gives me 4 and 1/27. 0 gives me 4 and 1/9 because you're adding 4 to this. Then 1 gives me 4 and 1/3. 2 gives me 5. 3 gives me 7. 4 gives me 13. And 5 gives me 31. So -1 we're at 4 and barely more. At 0 we're at 4 and a little bit more. At 1 we're at 4 and even a little bit more. At 2 we're at 5. At 3 we're at 7, 6, 7. 4 we're at 13, so it's 7, 8, 9, 10, 11, 12, 13. And I can't graph the other one. So there looks like there's an asymptote here, and then it's going to go up. If we switch the points, 4 and 1/27, -1, 4 and 1/9, 0, 4 and 1/3, 1, 5, 2, 7, 3, 13, 4, 31, 5. That won't fit, but I just put it up there. Alright, so we go 4 and 1/27, -1. So that's like right there. 4 and 1/9, 0. It's like right there. 4 and 1/3, 1, which is like right here. 2 or 5, 2. 7, so 6, 7, 3. And then 13, which is so 6, 8, 10, 12, 13, 4. Okay, so there will be an asymptote here, and then it'll go off forever. Okay? Alright. And again, the domain for this is x is greater than 4, y is all real numbers, whereas for the original, the domain was all real numbers, and the range was greater than 4. So. Oh, we got one more. Let's see, we have -4, -3, -2, -1, 0, 1, 2. When I graphed that, oh, I should change the color. I did all these in blue. So I'll use blue for the original. This is 11, 3, -1, -3, -4, -4.5, -4.75. Okay, so if I graph this, I get -4, 11, which would be 2, 4, 6, 8, 10, 11. -3, +3, -2, -1, -1, -3, -0, -4, 1, -4.5, 2, -4.75. So it looks like it's approaching -5, which makes sense by looking at the function itself. It has a -5 in it. Oops, so it should be more close to that. Okay, and if we flip them around, 11, -4, 3, -1, -3, -4, 4.5, -4.75, and then this becomes -3, -2, -1, 0, 1, 2. So we have 11, 4, 6, 8, 10, 11, -4. We have 3, -3. We have -1, -2. We have -3, -1. We have -4, 0. -4.5, 1. negative 4.752. So this would be the vertical asymptote now. And then it just kind of does that. Okay, so those are graphing again. The original and the inverse, just make sure you know that the domain and range switch are the inverse. Good job.